This is Algebra 2 at Trig, 3a.2b. We're graphing when we have an x on top of our fraction and an x on the bottom of our fraction. So our equation might look something like this. We have to recognize how the equation is drawn or written to know what method that we're going to be solving. In the past, we have worked with equations that might look like this. And in this case, we had a parent function we could use, a over x. But here we don't have a over x. We have an x on top, like we do here. So there is really no shortcut. But what we can use is symmetry. So we're not going to have to do as many calculations if we use symmetry. So let's listen to what we're doing, and let's go with that. So first of all, let's jump down to this one. To find the vertical asymptote, what did we do in the past? How do we find our vertical asymptote on the work you've already done? You take your denominator and you set it equal to 0. So to find the vertical asymptote, you must set the denominator equal to 0 and solve for it. So in this case, the vertical asymptote is x plus 2, because that's your denominator, and you're equaling it to 0. So that's a simple one. We can all find the vertical asymptote. X equals negative 2. So you know on your graph, you're going to have a vertical asymptote at whatever makes the denominator 0, because you cannot divide by 0. Negative 2 would make the denominator 0. Now we need to figure out where our horizontal asymptote is going to be located. In the past, we've used like a k value. When the degree of the numerator, that's the value on top, the degree is the exponent of the variable. So in the past, we didn't have a variable up top. So therefore, the degree was considered 0. So it was a, anything to the 0 power is 1. So a times 1 was just a. So if you don't have a variable on top, that degree is 0. When the degree of the numerator is less than the degree of the denominator, then the horizontal asymptote is y equals 0. And you could say, if you have a k value to it, you could say that it's y equals k. What we're facing down here, we're facing an x on top and an x on bottom. So when the degree of the numerator is equal to the degree of the denominator. Let's talk about that. What does that even mean? The degree of the numerator. The degree is the exponent. Like first degree means linear, second degree means quadratic. This is to the first degree. And the denominator happens to be the first degree. So those degrees are the same. The exponents are the same. Therefore, when the degree of the numerator is equal to the degree of the denominator, the horizontal asymptote is the ratio between the leading coefficients. Now, you have used this word before a lot recently, leading coefficient. So what is the leading coefficient of the top of the fraction? 3. What's the leading coefficient of the bottom of a fraction? It's the number in front of the x, which is 1. So what is that ratio, that fraction, top over bottom? The horizontal asymptote would be y equals the leading coefficient, 3, divided by the leading coefficient of the bottom, which can be simplified to just 3. So we're going to have a horizontal asymptote at y equals 3. So here we've come across two situations. One when the degree of the top is less than the degree of the bottom, and one when the degree of the top is equal to the degree of the bottom. Now the last situation would be, what if the degree of the top was greater than the degree of the bottom? Like an x squared over the x. That's when you can have a slanted asymptote. But we're not going to have slanted asymptotes in this class, so won't be our issue, but you might have that in a pre-calc type class. All right, so we're only going to have to worry about the top being smaller or the top being equal to the leading the degree. That's what we're looking at, the degree. So now we have figured out where our asymptotes are. Set the denominator equal to 0 for the vertical, and look at the leading coefficient, or really look at the degree. And in this case, we use the leading coefficients to determine y equals 3. So we have our asymptotes. Now, we're going to need to use the real equation. We got to use the real equation. We don't have a parent function to use. When the problem was simpler, we were able to use a parent function, a over x, and not worry about h and k. But we can't eliminate the 6 and the 2. So what is our vertical asymptote of the real equation? -2. So we put a -2 in that spot. Easy enough? That's what makes the denominator 0. That doesn't get us a y answer. All right? Now we need to pick numbers to the right of that vertical asymptote. Pick any numbers you want. 1, 2, 3. Or 1 to the right, which would be -1. 2 to the right, which would be 0. 3 to the right, which would be 1. You can do any numbers you want to the right. Now, what I would suggest is spacing it out a little bit. Because if you pick numbers really close to that, you're not going to have much of a change in the dots. So spread them out. So what is 2 numbers to the right of this? 2 numbers to the right of -2 would be 0. What would 2 to the right of that be? 2. And what's 2 to the right of that? 4. You can go any distance you want. I'm just suggesting to leave some gaps, space it out, do the best you can. Any numbers you want to use. So we're going to start with x equals 0. You're going to need to do calculations. Okay, and notice we're not using a calculator. You can do this. 11th grade math, we can pull this off. 3 times 0. -6. 0 plus 2. Okay, I don't expect you to do it in your head. Just write it down. What is 3 times 0? 0. Okay, -6. What is 0 plus 2? I don't expect you to do it in your head. Write it down. Now, what is -6 divided by 2? You can do this. See, do it by little steps. Don't hold it all in your head. So at 0, we got -3. So we're using the actual origin, the 0, 0. because we're using the real equation. So at 0, 0, we're coming down 3. And there's one of our points. Easy enough. Now we're going to calculate what it is for 2. So 3 times 2 minus 6. 2 plus 2. 6 minus 6 over 4. 6 minus 6 is 0. What is 0 divided by 4? 0. So when x is 2, we go 2 to the right, we're at 0. That's easy. Then we have one last number to calculate. So that's 3 times 4 minus 6. 4 plus 2. That's 12 minus 6. 6's cannot cross out. That's 6 over 6. What do we get? 1. So when we're at 4, we get 1. Let's pretend for some reason it wasn't so nice and we got 5/6. We don't need a decimal for 5/6. We would just come up here. We'd go 4 to the right. 1, 2, 3, 4. 5/6 is really close to 6/6, so it's really close to 1. But in this case, we did get 6/6, or a value of 1. So we're going to be right on the y value of 1. But even if it's a fraction, just try to figure out what is half the number, and are you more or less than it. The size of your pencil is going to take up all the other values. Just get super close to it. You don't have to be perfect. So now we've gotten as close as we can to graphing out that branch. All right, now we have our dots, we drew in our branch. We have 3 more points to do. You do have a choice. You could pick points to the left of it. Maybe since you went to the right, you'd actually go to the left. We went 4 to the right, you'd probably go 4 to the left, and then more. All right? Those would be logical points to pick. If you really like calculating these, go ahead and calculate more points. Most people would prefer not to recalculate. This isn't their favorite part of the math. So let's use the idea that these branches are symmetrical. So if the branches are symmetrical, now we're going to go to the intersection of the asymptotes, kind of like the new origin. From that intersection, we're going to count over to the right 2 and down 6 to get to our point. To the right, down 6. So where am I going to go from this intersection point? To the left and up 6. 1, 2, 3, 4, 5, 6. I think that's a lot easier than having to recalculate new points. That should be your friend. Now, from the origin, how far to the right do I need to get even with the next point? Had to go 1, 2, 3, 4, and down 3 to get to the next point. So we're going to go to the left 4 and up 3. We went to the right 4 and down 3. Now we're going to the left 4 and up 3. Because they have to be symmetrical to each other. And how do we get this last point? How far to the right do we need to go?
6.
Need to go 6 over and down how much? 2. So we're going to go from our intersection of the asymptotes. 1, 2, 3, 4, 5, 6. and up 1. And you didn't have to sit there and recalculate out all of these points. 2 points? Good call. There it is. Good job. So you graphed it. You did not have to calculate out 6 points. You only had to calculate out 3 points. Then you could count your others. What's your domain going to be? What's the domain? All real numbers except x equals -2. And the range, all real numbers except y equals the asymptote. The answers we can get can be anything but the number 3. We'll never get 3 as an answer. We'll only get closer and closer to 3. So now we flip our sheet over. We have a story problem. This story problem we'll be able to use our calculator for. Your long distance calling plans. You might not even know what that means. It used to cost different amounts of money depending on how far you called. So long distance cost more money than it did to call next door. Inside your area code and outside your area code. But you live with your cell phone, so that's all calculated in, and they charge you top price for it anyway. So long distance calling plans has a fixed monthly fee. It costs $4.95. That'd be nice if your phone only cost you $4.95 a month. And then you had to pay for how much you used it. 5 cents a minute. Okay? Now that's the way that the long distance plans used to work. So what we're going to be looking for is write an equation that gives your average cost per minute, M, during a given month. Write an equation that gives the average cost per minute. Well, what's the total cost per month? How would you determine that? Using this information, what is the total cost? How much does it cost you per month? We have $4.95. Now, if we said 5x or maybe 5m, the 5 is bigger than the $4. So you need to be sure that the units are in the same amount. So if these are going to be in dollars, these have to be in dollars. So it's very important you have your units correct. It's got to be cents if you're going to talk about cents, which is $0.05. And we're using the letter M. Now that's the total that it costs you each month. You figure out your number of minutes, you times that by 5 cents, and you add your $4.95 to it. Now if you want the average, that means we have to divide it by something. We're going to divide it by the number of minutes. So now we're going to know how much it costs per minute. So we type our equation into the graphing calculator. You could graph it if you want. Right? That's what the graph looks like. Those are the graphs we've been drawing. So that's not a surprise. we're only looking at the first quadrant because those are positive minutes and that's positive money. So that's why we're in the first quadrant. So we're going to look at our table. Why do you think we would have an error when x was 0? Or in this case, m is 0. In our equation, mathematically, we have 0 minutes. Probably in reality, you can't use 0 minutes in a month. Okay? So, but you can't divide by 0. All right, the table down here, the graph down here goes by 20. So I changed my my table by going to second window, by the way. This is kind of new. I went to table setup. I told it to start at 0 and to take steps. Change your steps by 20s. This is a new skill for you. So how much does it cost if you talk for 20 minutes? What is the average cost per minute? It was 29.75. You don't have to be exact. Just get up there, close to 30.3. At 40 minutes, what is the average cost? 17. A little bit less than 20. 17.35. 375. What's it going to be at? 60. We're at 13 something. At 80.111. So that's more than 10 still. What are we approaching? It looks like we're approaching 10. No doubt about it. But mathematically, what are we approaching? The degrees are the same, so we use the leading coefficients, so we're approaching 0.5. So the graph will actually keep dropping until we get down here to y equals 0.5. Okay? So if you look at 100 minutes, now we're under 10 cents. Below that, and we just keep going. And the graph, you can notice, no matter how many minutes you do, what are you getting closer and closer to? 0.05. You're never going to reach 0.05. That's because every minute you talk, it is 5 cents. So you can never get less than 5 cents because you're paying a cost that's more than 5 cents added to your 5 cents. So eventually, the $4.95 is irrelevant. It doesn't really affect the problem much. It's just you're going to get closer and closer to 5 cents. Okay? Never going to reach it. That would be your graph. What happens to the average cost per minute as the number of minutes increase? The average cost increases as the minutes increase. The average cost increases. It's decreasing. Sure. Can you be more specific? Because it decreases implies that it's going to decrease and go to negative infinity. It approaches 0.05. That's what happens as m increases. in terms of a bit of a summary, things that we have talked about in the past. The graph of y equals a over x is a rational function. That was stuff we talked about yesterday. And the graph of a over x minus h plus k has asymptotes at x equals h and y equals k. That was the old type of graphs we were doing. And we would graph these simple rationals using two branches. These graphs have one vertical asymptote and one horizontal asymptote.